Now, on 4 through 6, it's very similar for 1 through 3, except once we do the antiderivative, we then got to plug in. Now, remember, we plug in the top number, and then we do minus the bottom number plugged in. So that's our procedure each time. So on number 4, first thing I have to do is the antiderivative. Well, this is going to be a u substitution because I have natural log in the problem. Anytime you have natural log, the u is going to be the natural log. So I have 2 natural log x over x. U is the natural log of x. du is 1 over x. Well, I have exactly that. Notice I do have an extra 2, but that doesn't matter. I can just pull that out front. And then I can do u du. Notice, this is my u. And then the x here on the bottom, remember, that's really 1 over x. So now I can do the antiderivative. U squared over 2. 2's actually cancel, so that's nice. And then I plug in. Now, we're not done. This was a definite integral. So once I get to this step, I then draw a line, and I'm going to plug in e, and I'm going to plug in 1. Now, we're not using calculators on this, so there's a couple of things you need to remember. The natural log of e is 1, so this would be 1 squared, and the natural log of 1 is 0. Those are the only 2 natural logs you need to know, and I guess honestly you could have plugged it in your calculator if you had forgotten, but like if this had been natural log of 2, you would have left it as natural log of 2. You would not have plugged in the calculator to get an actual decimal. That would have been bad and it would have counted it wrong. So our answer is just 1 and we're done. Now number 5 is also a u substitution because we have parentheses to a power. And remember what we talked about in the last set of problems. When you have parentheses to a power, it's going to be u substitution. U is my what's in the parentheses. Du is the derivative. Notice I don't have a 6. I need a 6. So to fix it, I do 1/6 out front and a 6 inside. It's very important that before you go to plug in, you have exactly u and du. If you don't, it's not going to work out right. So then I can plug in u to the 5th, take the antiderivative, so u to the 6th over 6th, and plug back in. Now don't forget, while this is a definite integral and we're going to be plugging in 0 and 1, we have to plug those into x's. Those are x numbers. They're not u numbers. You can't plug them in up here. If you do, it's going to be wrong. So then we plug in the 1. So 2 minus 1 would be 1. And then minus, plugging in the 0. So this would be 1 over 36. And the other one's going to be minus 1 over 36. So we're actually going to get 0 for this answer. All right, for number 6, this again is another u substitution. They don't all have to be u substitution for definite integrals. They can just be just like number 1, except then you plug in numbers once you have that answer. These 3 were just u substitution because that tends to be what people miss more. So I did all of these as u substitution. The other ones are very basic, and you just do the antiderivative and then plug in. Notice we're missing the 2. We don't have a 2, so I'm going to do a 1/2 out front and a 2 inside. Remember, whatever you put inside, you have to put the reciprocal outside so that they multiply together to be 1. So 1/2 times 2 is 1. So that's how I can just stick a 2 in there. Now I can do my substitution and my antiderivative. Once I've got this, I have to plug my x back in before I can plug in the 0 and the 2. So plug the 2 in first, so that would be 4 minus 0, so that's actually 0. And then plug the 0 in. So I would have minus 4 to the 4th. And all I would do from here is just plug that in my calculator to get this number and then leave it over the 8. Okay, do not put it as final decimal, but there's nothing wrong with plugging in the minus 4 raised to the 4th in your calculator to get that number instead of doing it by hand. You know, by hand it's not hard, it's just 16 by 16, but you could also use your calculator. But leave the 8 on the bottom. Don't change it completely into a decimal. And that's how you do definite intervals.